Hello everybody, we'll be doing 5.4 notes, so solving proportions and then a review over radicals. So our objectives will be to simplify radical expressions, solve equations by square rooting, and then solve proportions as well. So we're going to go ahead and start with ratios. So a ratio is a comparison of two or more values. So if I were to say it in words, I'd say something like A to B. If I had it as a fraction, we just have that fraction bar in there, and then with a colon, A to B. All right, so the symbol just goes right between A and B. All right, a proportion is an equation where two or more ratios are set equal to one another. So if we could have A over B is equal to X over Y. So normally those are seen as fractions, so therefore we'd set up the two fractions. A over B is equal to X over Y. Alright, and then there's two ways we can solve. So solving proportions. A proportion can be solved by multiplying both sides of the equation by the common denominator. So if we see a common denominator here, so like I can imagine 6, where both of these have 6 in common, I can multiply my numerator and denominator by 2 and this side by 3. So when I do that, I end up with 10x over 6 is equal to 21 over 6. So since my denominators are the same, my numerators have to be the same. So I can just rewrite this as 10x equals 21, divide by my 10 to get x equals 21 over 10. And we can just leave it as a fraction. All right, and then the other way that we can solve is using cross multiplication. So if we take here my numerator of my left fraction, multiply it with my denominator of my right fraction, so 2 times 5x, and then I want to do the same thing with the other side, so that my 3 and my 7, and I set them equal to one another, I now have 10x equals 21. So I can go ahead and divide by 10 to get x equals 21 over 10. So the exact same thing that we got in that first example we did, because they are the same, we just did them slightly different. So the first one, you can find a common denominator and then multiply them together, or you can do the cross multiplication and top with the bottom, top with the bottom. All right, so let's go ahead and try a couple examples. So down here, for example 1, we have 3 over 7 times, or is equal to 5x over 3. So I'm going to go ahead and use the cross multiplication method. So I'm going to do 3 times 3, and then I'm going to do 7 times 5x. And then from here, I just go ahead and solve for x. So I have 9 equals 35x. Go and divide by 35 to get x equals 9 over 35. Of course, if you can simplify these at any point, then go ahead. I so far haven't been able to simplify either of the fractions I've created. All right, let's go and try another one. So for this one, let's go ahead and find a common denominator. So I have a 2 and a 9. Let's see, we can get 18 in common. So I'm going to have to multiply my right fraction by 2 and my left fraction by 9. The important thing to remember is we are 3x minus 4, multiplying the entire thing. I'm not just multiplying the 3, not just the 4, both of them. All over 18 is equal to 2 times 5x all over 18. Since my denominators are the same, my numerators are equal to one another, so I can create a new equation just with my numerators. 9 times 3x minus 4 is equal to 2 times 5x. Then from here, we'll just go ahead and simplify and solve for my x. So we'll distribute my 9. So I have 27x minus 36 is equal to 10x minus 27x from both sides. Negative 36 is equal to negative 17x divided by my negative 17. I end up with a positive 36 over 17 equals x. Alright, so there are 2 examples. Go ahead and try 3 and 4. I crossed out what I did so that I can still show you guys the problems. Go ahead and pause the video, try them out, and then here in a moment I will show the solutions. Alright, so there are my answers and the solutions. I used cross multiplication for both of them. Alright, let's go ahead and move forward to radicals now. That was the end of proportions. So simplifying radicals, we're going to use a factor tree. That's what we're going to be using the most is use, oops, sorry, my zoom. Use factor tree. Another thing to keep in mind is that you do all operations under the radical first. So before you take the radical, before you take the square root, you want to make sure you do all the operations underneath that first. All right, and then rationalizing radical expressions. So this is when it's in a fraction. So rationalizing means we have a square root in the denominator. What you are going to do is multiply the numerator and denominator by the radical in the denominator. So whenever we never want a square root in the denominator, so whenever we have it, we're just multiply the top and bottom by the same thing, and then it all works out. And we'll look at a couple examples of that. So let's go ahead and start with number 5. So we have the square root of 40. We want to simplify that. So a factor tree is just terms that multiply to 40. And there are lots of different terms we can use. The first one I see is 4 times 10. But let's see, we can also do 2 times 20, right? And we could probably do, let's do one more, which would be 5 and 8. So there are different things that we can go about doing this. And so your factor tree might look slightly different than your friend's factor tree, but you should still end up with the same result, even if you took a different path to get there. So I'm going to continue with the 4 and 10. So 4, I have 2 and 2. And my 10, I have a 2 and a 5. So from here, I want to circle any pair of numbers I have. So I have a pair of 2's, and that's it. I can't match up my 2 and 5. And what I simplified all the way down to prime numbers. So if I were to do 2, I would just end up with 2 and 1 again. And then I would, be doing that forever. So I'm going 2 prime numbers, and I don't have to go any further than that. All right, any pair that I have, I'm going to take out and put in the front of my radical. Anything that's left over is going to go inside my radical, and they are multiplying with one another. And then to simplify, I just need to multiply the 2 and the 5. Let's go ahead and put it over here. We end up with 2 root 10. Okay. Let's go ahead and take a look at when we have a fraction. So I have a square root in my denominator. I cannot have a square root in my denominator. So what I'm going to do is multiply my numerator and my denominator by the square root of 5. We now have 1 times root 5, and then root 5 times root 5. We can combine these and put these under the same square root. So let's put it over here. So we have root 5. We don't need to write the 1 in front unless you would like to, of course. And then we have the square root of 5 times 5. Square root of 5 all over the square root of 25. And the square root of 25, we just took it out, and we have a pair of 5s in there. So I now have the square root of 5 all over 5. And the nice thing about these, it's going to be very common where that same thing happens every time. So let me show you what I mean. If I multiply number 7, so we have a square root of 3, I'm going to multiply the square root of 3 on the top and bottom. In my denominator, I'm going to be left with 3. So by multiplying the square root in the denominator, we now get rid of the square root because we have 2 3's, which will give me the square root of 9, which just gives me 3. So that's a nice little trick that you can use to make it go just a little bit faster. And then, of course, my numerator, I just put the 2 right next to the root 3 because they are being multiplied, but I can't combine them any further than that, or I can't simplify it any further. All right. So go ahead, here is 8, 9, and 10. I scribbled out my work. Go ahead and take a second, pause the video, try these 3 problems. All right, so here are my answers and my solution, and you can see once again with like the square roots, I was able to just simplify them straight out. I didn't have to really do too much extra work. Okay, let's go ahead and try 11, 12, and 13 together. So 11, this is what I was talking about whenever we have operation, so we have exponents, we have this addition, we want to do that before we take the square root. So in this case, I now have 16 plus 9. Add those 2 together. I have the square root of 25, and of course 25 multiplies to 5 and 5, so my answer would be 5. Okay, number 12, very similar, but this time I have 5 squared plus 5 squared. So we have 25 plus 25. Then I can take the square root. We now have 50 when I add those together. So now let's go ahead and create a factor tree for 50. I have 5 and 10. And then for 10, I have 5 and 2. So I have a pair of 5s. So my answer is now 5 root 2. And both of these, if we did end up skipping a step, I'm going to show you what's going to end up happening. So we haven't gone over this review quite yet. We're going to go over the review on the next page. But if you remember, square roots take out squares. So if I have something like that, they cancel out. If you were to do that step first, of course we would have, and you're like, oh, well, I can take it out that way, we'd have 5 plus 5, which is 10. And that is nowhere close to what our actual answer is. So you need to make sure that you're doing everything under the radical before you try to take the square root and work with the square root. All right, and then 13. We have another rationalizing the denominator. So of course we have that square root in my denominator. So I'm going to multiply the top and bottom. I now have 6 root 3 all over 3. The difference between this one and the ones we were just doing, the 6 over 3 can be simplified because this is a fraction, right? So in other terms, I could write it like this because I am just multiplying everything in the top. So if I wanted to, I can, put some parentheses around it and be like, yeah, we have a fraction and then we're multiplying it by root 3. But that can get kind of confusing at times. But so here we have our 6 and 3, and we can simplify that even further. So I need to find a common number between 6 and 3. Of course, 3 is the common number. So what I'm doing is dividing both numbers by 3. So I end up with 1, and then I end up with 2. So I now have 2 root 3. So whenever, if you have a fraction that you can simplify, make sure you simplify that and not leave it as, 6 over 3, 4 over 2, that kind of stuff. All right, go ahead and try 14, 15, and 16. Give you a second, pause the video, then I'll erase the green so you can see the solution. All right, there we are. For certain numbers, so like 625, I wanted to point that out. I didn't want to sit there and make a factor tree, and it did seem like a number that could be square rooted evenly. So I just plugged that into my calculator, and it's a little button that just looks like that. It might have an X underneath it. So you would put your number 625, and then you'd press the button with the little X, and then it would take the square root of 625. And then I was able to see, oh, well, 25 goes into 625. All right, but if, of course not, you can always resort to your factor tree. Your factor tree will always work no matter how small or big it is. All right, let's go on to the last page. So adding radical expressions. So the important part of adding radical expressions is that we need a common radical to add or subtract, which means we also have to simplify all radicals. So simplify all radicals as far as you can, and then you're able to combine. So for example, if I have 2 root a plus 5 root a, I can combine these because they both have a underneath my square root. So if it was the square root of 2, I can combine them. 3, and so on. So I now have 7 root a. I was able to combine the two numbers in front, the coefficients, and add them together. Now, if I have 2 root a plus 5 root b, well, I cannot combine that because we have an a and a b. So that would be if we had like a 2 and a 3. We would not be able to combine those together because they are different. All right, so therefore, we cannot combine this one. Okay, so let's go ahead and take a look at example 17. So I'm first going to start with my 25, which I can reduce. We have 5 and 5. We have a pair, so I'm going to take that down here. I'm just going to create my new equation with everything simplified. My 2 root 3, my 3 cannot be reduced any further, so I'm just going to be left with 2 root 3. Let's go ahead and take a look at the 75. I can definitely reduce that. Since it ends in a 5, I know that it is going to be multiplied by 5. Even if I'm not quite sure right away, I can plug that into a calculator, 75 divided by 5, and you're going to get out 15. And then I can simplify further, so I have 3 and 5, and I have a pair of 5s. So now I'm left with plus 5 root 3. And I can't simplify my negative 3 any further, so I'll go ahead and just write that off to the side. All right, so first, let's start with this 5 out front. So the 5 doesn't have any radical whatsoever, so I'm going to combine it with something that does not have a radical, which would be my negative 3. So I can go ahead and combine these two together. So I now have 2. Now I'm going to take a look at my next option. I have root 3. Oh, look, I have another root 3 here, so I can combine these two together. So I now have plus 7 root 3. Okay, and there's my final answer. So I simplified as far as I could, and then I combined with common radicals and non-radicals. So if something does not have a radical, you can also combine those together. All right, go ahead and try number 18. Pause this video, and then I will erase the green so you can see the solution. All right. There you go. We were able to reduce the square root of 8 and the square root of 9. All right, and then here's our review on solving equations by square rooting. So I kind of talked about this a little bit on the last page, but very briefly because I knew we were going to talk about it here. So when we solve equations by square rooting, the first thing we need to do is isolate the variable squared. So it's okay if it's something like x squared, as long as there's nothing around it. There's nothing being added. There's nothing being multiplied out front. If you have your variable squared all by itself. Once you do that, you can take the square root of both sides, and that's going to get rid of your square. So you need to isolate your variable squared, and then as soon as you get that by yourself, you're going to go ahead and take the square root of both sides. All right, and then as a reminder, your answer will be plus or minus. So after you take the square root, whatever you take the square root of will always be plus minus. All right, and then also another thing to remember is that you cannot square root a negative number. Okay, so let's go ahead and try a few examples. So for 19, I'm going to go ahead, my goal is to get my variable squared by itself first. So I'm going to add 5. I now have x squared equals 16. Take the square root of both sides. I get x equals plus or minus 4. So the square root of 16 is 4, but my answer is plus or minus 4. All right, let's take a look at number 20. So I'm going to go ahead and subtract 2 from both sides, and then I have 3x squared equals 28 divided by 3. I cannot reduce this fraction, so I'm just going to leave it as the fraction. When I take the square root, though, so when I take the square root, I can take the square root of each individual number so that I can simplify my fraction as much as I can once I have those radicals in there. So I now have x equals plus or minus the square root of 28 all over the square root of 3. Of course, I don't want my 3 in my denominator, and I can also reduce my radical in my numerator. So I'm going to do that first. So I have 28, which ends up being 7 times 4. Oops. Not 4 times 4, 7 times 4, and then my 4 is 2 and 2. So I now have a pair of 2's and a 7 left over. So let's write this up here. X equals plus or minus 2 root 7. I do not want to write a 7 today, apparently. 2 root 7 all over the square root of 3. And to get rid of that square root in my denominator, I'm going to multiply the top and bottom by the square root of 3. I now have x equals plus or minus. My denominator is just going to be 3. And my numerator, since we are multiplying these two radicals, I can put them under the same one to get 21. So the only time you have to worry about a common radical is when you're adding or subtracting. As far as multiplication goes, you can just multiply them straight together. All right, then 21, I'm going to go ahead and subtract 4 from both sides. Negative 2x squared equals 6. Divide by negative 2x squared equals negative 3. We cannot equal a square to a negative number, so this one is going to be no solution. All right, so let's go ahead. 3 more problems. Lost 3 problems. Go ahead and give them a shot. Pause the video, and then I'll erase the green so we can see the solution. All right. Here we go. So 22, 23, and 24. go ahead and take a look at the solutions. One thing I do want to point out is for number 24, if you notice that we had a negative 16 over here and you're like, oh, it's no solution, you do have to make sure you are going through the entire process before you decide no solution. Yes, it is currently equal to a negative number, but once we add the 1 and divide by a negative 2, we end up with a positive number to give us a solution. So it's okay if it is initially equal to a negative number. It's if just the individual square is equal to a negative number. All right, and that is the end of this section. Please make sure if you have any questions, let your teacher know, rewatch the video as needed, and then have a wonderful rest of your day.